In part 19 of our modelling fundamentals, we're going to have a look at the manual connections and what we've got to do to manually create objects that we can't do automatically. In this process, we're going to start piecing together some of the stuff that we've been learning to get us to this point. So for this example, you can see over here that I've got a vertical and a horizontal member. So I'm just going to spin this around a little bit here, and you can see they don't line up. Now the reason is I'm going to put a compound brace between the two, which is about as tricky as sort of we get in structural steel. So I'm going to kick off by just drawing a construction line to work on, again using the skills that we've learnt sort of up till now. So we're going to set an origin point, and I'm just going to come up maybe sort of probably 2 meters or something like that, just a random amount, and I'm going to set a new origin point here and drag it back just a non-specific amount here. Alright, just a construction line here to give us something on a compound angle. Alright, so the next step that we're going to do is we're going to place I'll probably put a piece of angle line. Alright, equal angle, and let's make it 100 by 10. I'm just going to insert it centrally by 2 point, bottom to top, and we'll rotate it around here. Now the key thing to remember is have a look at the ACS there. The ACS is global, which means if I come to the plan view here, you can see we're looking directly down on the steel. The steel is not sort of twisted on some weird angle when we're looking down on top. We're looking straight down on top of the steel, even though it's coming up on an angle. So that's the important thing to remember about stuff running on compound angles when we're inserting it. Make sure your ACS is set globally. Alright, our next step is going to be that I want to connect cleats up to that new brace. So what we're going to do is I'm going to set my object view centered onto the face that I want to run the cleat on. So object view centered. Now the important thing here, I don't want to align the view. This allows my brace to run horizontally, which makes it really easy to work on. So I want to look at this face here, and you can see because it doesn't rotate it, it just keeps it horizontally and makes it really easy for me to work on this, and I can put the cleat straight on. So I'm going to make the cleat out of maybe 100 by 10, so I want to choose flat steel, 100 by 10, and it doesn't really matter where I insert this because I'm going to move it later. Alright, because in 3D I really don't know where I'm going to be able to snap this to, but you know, sort of anywhere on this face here I'm going to start from, draw it in, and I'm going to move it in a second. Okay, so I'm just going to lock it here, I'm going to drop the steel in, we'll rotate it once, and now we'll change our view around so we can see where that went and we can move it accordingly. Alright, so accept that. Change our view, so object view centered. Again, I don't really want to have a quirky view, so okay, and you can see there, put it smack on the center line. It's not always going to put it there, so just be a little bit careful, always check your view. So I'm going to move that 5 millimeters, placing that cleat on the outside face of my angle, like that. Alright, so that side of things works very, very cool, and very simple. It's one of the things that ProSteel is very good at, is this kind of work of free-forming things. Okay, so the next thing I've got to do is I've got to work out where that cleat runs into my horizontal beam. And what we're going to do is we're going to use our collision detection to work out where the interference point is for it. So before we kick off on the cleat, let's shorten the cleat up, and I'll actually get the brace 20 mil off the steelwork first, so we know where to put our holes while in our cleat while we're working on it. So I'm just going to shorten that cleat up, and then I'm going to go object view centered, don't align the view, and we're going to have a look at the side of the angle. So we'll get the angle set up first, that way we know sort of where to put our holes and stuff. So we're going to drag this intentionally interfering into our beam. Then we're going to use collision detection and work out the interference between those two objects. Alright, now this is sort of pretty simple, but you can see there's a 3D solid where the two interfere. And you can use this for anything. You can use it for hip rafters or valleys and so forth, but using it as a modeling tool like we've said in previous videos. So this will give us an idea along this point here where we need to cut this off at. So I'm just going to set that view back up and we're going to chop this off. Now the location I want to cut this off is this intersection point right here where the brace actually hits the underside of the beam. Now I don't need to cut this off at a construction line, but it's easier for the demonstration if we do this. So I'm going to come up here to R1, which is modify, and we're going to go cut at a line. Now just for your reference, from this intersection point here, if I snap to there and had this one here ticked on, which is a straight cut, ProSteel would automatically cut the object off square for me, which is pretty cool. The other thing that I want to point out to you here is this number 1. If I set this to 20 from wherever I nominate, so I'm going to pick the wayside of the line and it's going to ask me to pick the line next. Alright, but I could go point and pick like snap to here if I didn't have a construction line. It's going to go 20 mil past wherever I choose. You watch this. See? So that gives me 20 mil clearance steel to steel based on the intersection point. Very cool. And I'm going to just delete the solid bodies left over, or alternatively I could come to the collision detection and clear the body there. Our next step is going to be to do exactly the same thing with this cleat here. So I'm going to grab it by its end grip and drag it so it crashes into the beam, and we're going to do a collision detection on that exactly the same way. So collision detection, grab my two objects, and there is my intersection point. Now this time we don't want to cut this off square. This time we do want this cleat here to match the profile of the bottom of the beam. So if it was a compound cleat, it would be very important to look square onto this face of the cleat, and the first line at the underside of the beam is where it interferes. So I don't want to cut it off at a distance. I don't want to cut it straight. I want to cut this as the wayside, 2 points from and pick anywhere on this object. So I could even go nearest to or something like that if it helps. Okay, and don't forget you've got the collision body there that needs to be got rid of as well. So there we go, the cleat fits, our steelwork's 20 mil clear. The last thing we've got to do is put some holes in this. So the next thing we're going to do is come over to the drill command, and I want to drill a pair of holes that going to take a 16 diameter bolt with 2 mil clearance. I want those holes to be drilled on the shape center because we're drilling a shape. Right, and if you remember back from my earlier videos, I described how to set this drilling up. So along the shape length, so here in across I want to disable this, so disable it by putting a 1, and along the shape length I want 2 holes at 70 centers. Alright. Okay. Other than that, I want to place my hole drilling at center. Now, before I go into this, I wouldn't normally, but I'm just going to draw a couple of construction lines so you can watch what I'm doing. So, like I said, I wouldn't normally do this. I'd be just setting it up based on an origin. But I'll do a construction line and I will offset, move parallel, 35 mil, and I'm just going to set my hole centers out so you can watch what I'm doing. So in 35, 70 centers for my holes, and then 35 mil edge distance to the end of the support cleat. So that last line is the support cleat. Now, something to bear in mind, these are where the hole centers are going to go. is here, but just bear in mind that my hole centers are on gauge, so they're not spot on at shape center. I'm going to have to actually offset it. So it's something to just bear in mind, where exactly do you want your holes placed. Alright, so 35 in, I want here is my center of my hole set. Okay, so I'm going to work that out here off the settings. Settings, I want a rectangular offset. Now, in the X and Y of my object, I want to come 70 mil in to the center of my hole set, which is 35 plus 35 in between the hole centers. And if we have a look here, here is the origin of my cleat, which is origin of my shape, which is down the bottom. This is a positive direction, which means I'm going to have to set my holes in an offset negative if I come from this end heading back this way. Does that make sense? So positive from the origin forward, negative if I've got to head back towards the origin. Now, from the center, I want to come out an additional 5 mil to get it out on gauge line. So let's have a look at that and see where we go. Alright, now the key thing to remember with drilling is you mightn't always get it perfect, and that's okay. The hot ticket is don't panic. So I'm going to pick anywhere on this end. I can pick out here, I can pick this corner, anywhere I want, because it's going to offset it for me. And you can see those holes have gone the wrong side in the Y that I thought it was going to. Don't panic. It's still live, which means if I change this on the fly, it will update on the fly, which is really cool. Don't panic. Have a look. Did you get what you wanted? If you didn't, make the adjustment before you get out of this dialog. It's not finalized till you hit OK. Alright, so let's hit OK on that. Now, one of the things I'd like to point out is, before we go any further, if I was to do any additional drilling, it's going to be based on the last settings used within here. The last settings that we used within here had this rectangular offset, so please change it to no offset before you go and drill anything else. Okay, otherwise you're going to get caught. So I'm just going to match drill now the thing with the holes to the thing without the holes, which is a really simple command. From there I can go to bolting. Make sure you match the diameter and the work loose to the hole that I drilled. So I want an 8.8. And it should put the bolts in for me. The diameter isn't as important as the work loose is, I must point out. And then I'm going to grab that grip and drag it back for the cleat. Alright, so that is everything we need to complete that cleat off, and we could do the exact same thing up the other end. So that's how it looks. Nice and easy to do. Please practice that. You want to get good at being able to create all this sort of stuff and utilize our collision detection for helping us with our modeling. Now, the final thing I want to have a look at is our part descriptions. So let's put a base plate on here because we have to, and I'm not going to bother about drilling it. I just want to show you how this works, because naming conventions allow us to actually get manually created components to work like automatic ones with the rules. So I'm just going to draw a piece of flat in here, rotate it round. Got it the wrong way, so I'll just fix this up. There we go. Now, at the moment, this here is just a piece of flat. ProStructures dimensioning and detailing rules do not know what to do with that. So what we're going to have to do is we're going to have to give it a naming, like a part description, so that it meets the criteria of the rules that we've got set. Now, this is pretty simple for anything that we manually create that we want dimensions to work for. Come up to the ProStructures properties of the object, and you can grab more than one, and you'll need to navigate not to general data but our part list data, and under part list data the assignment. Alright, now down in the list of assignments you'll see description here. If we expand the flyout out beside that, we'll have 3 separate lists here of sort of assignment or descriptions for our objects. Mine or the one for Australia, is the second one. All right, this one here has been put in for Australia. And what I want you to do is match the type of object that you would have used the automatic connection for. So end plate, base plate, purlin cleat, stiffness straight, or brace cleat straight for all the automatic connections. All right, ignore all the rest of them. Don't worry about the rest of them. These are the key ones here. So this guy here, had I used an automatic connection, would have been a base plate. All right, the fact that I manually drew it doesn't matter. Okay, that now in the rules for detailing will be considered as a base plate. Now, I have done a separate video for how to get it to come up in base plate marking plans as well. So please look for that video in my other video lists.